Good day. So you're now on the fourth example, a marketing example. So the problem here is the big department store chain has hired an advertising firm to determine the types and amount of advertising it should invest in for its stores. The types of advertising available are television commercial, radio commercial, and newspaper ad. The retail chain desires to know the number of each type of advertisement it should purchase in order to maximize exposure. It is estimated that each ad or commercial will reach the following exposure and cost. So, he wants television to reach the 20,000 exposure with only cost of $15. Then with the radio commercial, and an exposure of 12,000 that only costs 6,000. And with the newspaper ad, 9,000 exposure and cost of 4,000. So the company must consider the following constraints. First, the budget limit for advertising is $100. The television station has time available for 4 commercials. The radio station has time available for 10 commercials. The newspaper has space available for 7 ads. And the advertising agency has time and staff available for producing no more than a total of 15 commercial or ads. So for the decision variables, this model consists of 3 decision variables that represents the number of each type of advertisement produced. So x sub 1 is equals to number of television commercials, x sub 2 is equal to the number of radio commercials, and x sub 3 is equal to the number of newspaper ads. Objective function. So it has a different objective function than the rest. It does not maximize profit or minimize cost, but the audience exposure is to be maximized. So formula is maximize z is equals to 20x sub 1 plus 12x sub 2 plus 9x sub 3. Where do we get the 20? That's the exposure. Z is the total level of audience exposure. So that's 20. X sub 1 is the estimated number of people reached by television commercials, and so on. So the model constraints. First constraints reflect the limited budget of $100. So, the exposure is less than or greater than $100, where the 15,000 is the amount spent for television advertising, 16,000 x sub 2 is the amount spent for radio advertising, and 4,000 x sub 3 is the amount spent for newspaper advertising. So the next 3 constraints represents the limitation of commercial. So x sub 1 is less than or equal to 4 television commercials. X sub 2 is less than or equal to 10 radio commercials. X sub 3 is less than or equal to 7 newspaper ads. For the third constraint or final constraint specifies the limitations of the advertising firm, where x sub 1 plus x sub 2 plus x sub 3 is less than or equal to 15 commercial and ads. So it has a limitation of 15 only. for the model summary. So the complete linear model programming is summarized as maximize z is equals to 20x sub 1 plus 12x sub 2 plus 9x sub 3, where this is the cost and less than or equal to the constraint of $100. Then these are the other constraints where x sub 1 is less than or equal to 4, x sub 2 is less than or equal to 10, and x sub 3 is less than or equal to 7. Then x sub 1 plus x sub 2 plus x sub 3 is less than or equal to 15. So, for the solution analysis, let's leave it first. We're going to go with the computer solution with Excel. So, here is how it is solved. So first, this is the type of advertising: the television commercial, the radio commercial, and the newspaper ads. And then, this is the number of advertisement he want to produce in each commercial. So he want to produce a 1.81 commercial, 10 radio commercial, and 3.182 commercial. And then, the decision variables are contained in cell E6 to E8, colon E8. So ito, this is this one. This is the decision variables. E6, cell E6 to cell E8. Then, the formula for the objective function in cell F10, this one F10, is the sum product of E6 to E8 and F6 to E8. So you're just going to 1.818 times 20,000 plus 10 times 12,000 plus 3.182 times 9,000. Or you can simply put here on the cell like this one equals sum product. That's a sum product, okay? Parenthesis, open parenthesis, E6 colon, because going to add from E6 to E8. So you're going to use colon E6 to E8, comma, let's multiply F six colon F 8 close parenthesis. I'm gonna enter that, or just long press this one, put it here. This is the cost. It is also shown in the table. Oh, these are the constraints, the availability of the commercials. Okay, so we're now going back to the solution analysis. So the solution analysis is 8x sub 1 is equals to 1.82 television commercials 1.82. So this is what he is talking about. This one in the solution analysis. So in solution analysis, x sub 1 is equals to 1.80 television commercials, x sub 2 is equal to 10 radio commercials, and x sub 3 is equals to 3.18 newspaper ads. While the z is equal to 185,000 audience exposure. So this is a case where non-integer solution can create difficulties. It is not realistic to round 182 television commercial to television commercial. So it shows that it doesn't exceed to $100 budget limitation. Thus, the store must either increase its advertising or plan for 1 television commercial, 10 radio commercial, and 3 newspaper ads. The audience exposure for this solution will be 167 people or 18,000 fewer than the number, almost a 10% decrease. There may be in fact to be a better solution than this rounded down solution. Thank you for listening.